All right, now we're going to talk a little bit more about composition as well as the other 3 trig functions in our section 5.5/6.4 day 2 notes. Still talking about inverse trig. So in this problem, I'm going to work on this composition from the inside out. So I'm going to find what the sign at root 3 over 2 is, which is pi over 3. I'm going to find the cosine of negative 1, which is pi. Then I'm going to find the tangent of this. Well, I got to add them together. So this is the same as 3 pi over 3. So I'm going to find the tangent at 4 pi over 3, which would be root 3. Similarly here, I'm going to find the sine of root 3 over 2, which I just found over here, so pi over 3. I'm going to do 2 times that since there was this 2 here. So I'm going to have sine of 2 pi over 3, which is root 3 over 2. All right, so those are unit circle values. So in 3 and 4, they gave us values that aren't unit circles. So then we're going to draw a triangle when we have values that aren't on the unit circle. So sine inverse is either in quadrants 1 or 4. Since this is a negative sign, it's going to go in quadrant 4. So it's going to be negative 4 over 5, and it's a 3, 4, 5 triangle. Now they want me to find the cotangent of that triangle. And so I'm going to find the cotangent of the triangle. I know the cotangent's x over y. So the answer would be 3 over negative 4, or negative 3/4. Same here, I have negative 7/8. I have cosine negative, so that's going to go in quadrant 2 with adjacent over hypotenuse, or x over r. Now I need to find this missing side, and it's not a special triangle, so we're going to do negative 7 squared plus, we'll call this y. Y squared equals 8 squared, so 49 plus y squared equals 64. Y squared equals 15, so y is going to equal the square root of 15. So my sine would be my y over my r, so it's going to be the square root of 15 over 8. Similarly here, I just have a variable, so we're still going to draw triangles for both of these. So tangent is positive, so that's quadrant 1, and it's going to be y over x, or opposite over adjacent. So to find my hypotenuse, I need to do Pythagorean theorem. So c is going to equal the square root of x squared plus 1. I know you cannot square root x squared plus 1. You cannot square root over addition. So I need to find the sine, which would be opposite over hypotenuse, or y over r. So it's going to be x over the square root of x squared plus 1. Similarly here, I have 2x over 1. So I'm going to draw a triangle. Sine is in quadrant 1 of 2x over 1. Now to find this missing side, I'm going to end up doing, let's call it a squared plus 2x squared equals 1 squared. A squared plus 4x squared equals 1. So I'm going to subtract it over and then take the square root. So I'm going to have 1 minus 4x squared. Square root of 1 minus 4x squared. So I'll put that in the spot for a. So I need to find the cosine. So that's adjacent over hypotenuse, or x over r. So it's going to be the square root of 1 minus 4x squared over 1, which would be the square root of 1 minus 4x squared. In 7, we also have values that are not on the unit circle. So I basically have one angle that I don't know minus another angle that I don't know. So I'm going to call this triangle A, and I'm going to call this triangle B. You could also call it triangle X, triangle Y, but I'm going to draw 2 triangles. So one to represent A, where sine is negative, and one where tangent is positive. And then I'm going to do the cosine of A minus B. So I'm going to use my sum formula. So cosine A, cosine B plus sine A, sine B. So cosine of A is 3/5, cosine of B is 4/5, sine of A is negative 4/5, sine of B is 3/5. So I'm going to have 12 over 25 plus negative 12 over 25, which is going to give me 0. Similarly, number 8, I have the cosine inverse of some value I don't know, so I'm going to draw a triangle for this ratio. So cosine's positive, so So be in quadrant 1. I'm going to get a 3, 4, 5 triangle again. Now I'm going to do cosine of a double angle, because that's what this 2 means, double of this angle. So cosine double angle has a couple formulas. I'm going to use cosine squared minus sine squared. So cosine of the triangle would be 4/5 squared. Sine of the triangle would be 3/5 squared. So I'm going to have 16 over 25 minus 9 over 25, which would give me a final answer of 7 over 25. All right, now we're going to talk about the other 3 trig functions: secant, cosecant, and cotangent. So if we look at a secant function, just like the other 3 functions we already talked about, we have to restrict the domain of secant, and so we have an inverse. So my domain of my inverse secant function, well, it's going to go from negative infinity, stop at -1, start at -1, and go to infinity. So my domain is going to be negative infinity to -1, union 1 to infinity. My range is going to start at 0. It's going to approach this asymptote at pi over 2, then keep going and stop at pi. So there's 2 ways we could write this. So it's going to start at 0, go to pi over 2, but not touch pi over 2, and then continue on from pi over 2 to pi. Or we could say that we're really going from 0 to pi, but y just can't equal pi over 2. But it can equal everything else in between. Either notation of these 2 works. Similarly with cosecant, I can see that my domain is going to be negative infinity to -1, and then 1 to infinity. And then my range is going to go negative pi over 2, can't touch 0 to pi over 2. So again, there's 2 ways to write that. We can write it with a union of negative pi over 2, 0, union 0, pi over 2, because again, there's that asymptote at 0. Or we can say the range goes negative pi over 2 to pi over 2, but y just can't equal 0. Either way works with me. For cotangent, it's going to go 0 to pi. My domain is going to be negative infinity to infinity, just like tangent. And my range is going to go 0 to pi, but no square brackets on the ends because there's those asymptotes, because cotangent's undefined at 0 and at pi. So these are going to follow our other 3 trig functions when we talked about our half circles. So quadrants 1 and 4, this was sine inverse and tangent inverse. Now it's also going to include cosecant inverse. Our half circle that includes 1 and 2, this was cosine inverse. Now it is also secant inverse and cotangent inverse. So you're going to have to remember which restrictions belong to which functions and which half circle you're going to use for each of those functions. So speaking of that, we're going to apply it now. So cosecant is like sine. So this would be the same as saying the sine inverse of root 3 over 2, which happens at pi over 3. Arc cotangent. So I'm thinking about this as x over y. So where does the x over y give me negative root 3 over 3? And that's going to be at 2 pi over 3. Secant is negative root 2. This is the same as saying the cosine inverse is negative root 2 over 2, which happens at 3 pi over 4. And now let's do some composition. So sine at negative pi over 2 is -1. So I want to find the cotangent. Where's the cotangent -1? Well, that's in quadrant 2 at 3 pi over 4. Now with 5 and 6, these are triangle problems. So I have cotangent is x over 1. So x over 1. And so that means my hypotenuse is going to be square root of x squared plus 1, because I would do x squared plus 1 squared equals c squared. Solve for that missing side. Then the secant is r over x, or the reciprocal of cosine. So it's going to be the square root of x squared plus 1 all over x. Similarly in 6, I'm using a triangle because -7/2 is not on the unit circle. Cosecant is negative in quadrant 4. It's going to be hypotenuse over opposite. Notice I gave the negative to the 2 because your hypotenuse, that's 7, should be positive. Your hypotenuse is always positive. So to find that missing side, we'll call it x. Use some Pythagorean theorem. All right, so I'm going to get the square root of 45, which can be broken down into 9 times 5, which means it's the same as 3 square root 5. So this x side is 3 square root 5. To find the cosine, you're supposed to do adjacent over hypotenuse, so that'd be 3 square root 5 over 7. Now this bottom section, you're using your calculator, so just be very careful about how you type these in. There is no inverse secant, cosecant, or cotangent buttons, so we have to use the inverse sine, cosine, and tangent. So secant is going to be the inverse cosine, but then you're going to do 1 over, so you're doing the reciprocal of that value, and you should get 1.166. Again, be careful that you're in radian mode. Cosecant would be sine, and then we're going to do the reciprocal, sine inverse. And so we're going to get negative 1.20. Okay, so now cotangent's tricky because negative cotangent is in quadrant 2, but if I use the tangent inverse, that's actually, tangent inverse puts me in quadrant 4. So to get to quadrant 2, I have to add pi to my answer to make it on the other side of the circle. So this is only true when cotangent is negative. You have to add pi. So kind of keep that in mind when you're doing these on the calculator. And so for this one, you should get an answer of 2.871. Arcsecant is the same as secant inverse, so I'm doing cosine inverse of 1 over negative 1.52. That's going to give me 2.289. Arc cosecant, same as sine inverse. So 1 over 12, which is 0.083. And now this cotangent's positive, so I can just use regular tangent inverse because it'll give me an answer in quadrant 1. Oh, sorry, 1 over that. And so it's going to be 0.188. All right, if you'd like to try these examples at the bottom, feel free, and you can check your answer with the Notes answer key.